All right. Hello, everyone. So I think my voice is finally to where I can do this slideshow. So let's take a look. This is the B&M Metals training class. This is the first training class I'm doing on light gauge or steel members. So I'll do a separate video on red iron members. This is specifically the galvanized light gauge members that we run in-house. So some of these things you'll notice that we do run in-house. Other things we will order in from other companies, and those may change over time, and if they do, we'll send out amendments to this training. But for now, these are the main members. So this should give you a really good overview of what these light gauge members are. So we call these steel members because you'll notice there's a lot of different categories and things. So let's just jump right into it. So what are steel members? Steel members refer to the steel components that kind of make up the structure of the building. So there's a lot of different parts of a building, right? You have the sheeting on the outside, you have the foundation, which is the concrete, the trusses on the roof or whatever. The steel members are typically the skeleton of the building. That can be made up of a bunch of different types of members, which you'll see in just a minute. But yeah, they are, they make up the main structure. That's what holds everything up. So often they are structural. There are a lot of cosmetic uses for these members as well, which you'll see. So like I said, some are manufactured in-house. Others, we just resell them, and I'll show you which ones. And then there are many names for different types. So this is a big one. You'll notice that many steel members have a lot of different names, and this can be frustrating, but in the industry, it's common to hear multiple names, so it'll be, important that you familiarize yourself with those alternative names. So a couple terms, light gauge. So light gauge refers to any galvanized members that are from 10 gauge to 29 gauge. So there's a pretty wide range of gauges, 10 gauge being probably the heaviest thing you'll ever see referred to as light gauge. 29 gauge is like tough rib, right? That's the lightest thing that we run here. So you will see some pest control stuff at like 30, 31 gauge, but 29 gauge is about the lightest thing you'll ever see. Gauge, and then like I said, gauge is the thickness of the metal, smaller the number, thicker the gauge. So you should know that from metal panels, but it's important to remember that here. So this is just a quick shot of kind of what some common steel members are. So like we have C-studs here, which we'll look at, or C-channel is kind of your main structural member, is probably the most important thing to learn. You have noggin or track. We call these U-tracks. They also go at the bottom and at the top as well. You'll see box studs. We'll talk about those. Those kind of typically make up the jambs of a door. It's just two C-channel that are overlapping each other. And that's about it really for this page, but there's a couple of things we'll show you. Sometimes you have a base trim, which may be an angle, things like that. So let's just jump right into the first big thing, which is how steel members are named. There's a very specific naming convention that we use for all of our steel members. Now, this is pretty much the industry standard. There will be some changes between multiple companies. Some companies use this industry standard, some companies do not. But this is the one that we're going to use because it's the most widely used standard. So basically, you're breaking the member down into its parts to create a label for it. So this will also be, let me see if I can go back to that. This will also be the SKU in our computer. So that's kind of nice. All right, there we go. So 1050 will be the first number, right? And that typically refers to the depth of the member. So now the depth of the member is obviously the width of the member. So this is the biggest part of the member. Typically, if you were laying the member on its back or on the ground, this is going to be the width of the member as it lays on the ground. So that is the depth. So 1050 would represent 10.5 inches or 10 and a half. Okay, so you have to be careful because typically you'll see four numbers represented here. Sometimes it can be three. For example, like 525 would be 5.25, right? Or 5¼ inches. 600 being 6 inches. The minimum number you'll see is 3. So no matter what, you'll see at least 3 digits. 462 is kind of a tough one, but you'll see this a lot. This represents 4.625 or 4 5/8. You'll most likely see this when it comes to the flange, because 1.625 is the most common flange width. So member, the next is like an abbreviation for the member type. Again, these are mostly industry standards, but you will see some differences from different companies. Often they'll have a description next to this label that will tell you exactly what it's called. So that's kind of nice. But so S typically means stud or C channel. T equals track or U channel. H equals at channel. L is angle. F is flat. Z is Z, and E is Eve. So you'll also see B for box, which, like I said, we're going to bring those in a later video as well with some more complex members where we'll talk about beams and things like that. But you will see these in the industry pretty commonly. Then you'll see the flange. The flange is going to typically be the other side of the steel member, the height. So if you were to lay it on the ground on its back, that would be how far it is above the ground. So the flange on a angle, for example, is just the one side. If the flange on a C channel or a U channel would be to the left or to the right. The lip and the return is only on C channels. So it's basically like when the stud comes back towards itself, it closes off the stud. You will not see anything on the member name that says that it has a lip other than that it is a stud. So when it is a stud, that means it has a return. If it's a T, that means it does not. So like I said, that can be a little bit confusing, but that's typically what you'll see designating the, whether or not it has a lip, as if it has it's a stud member. The mill thickness. So this can be a little confusing as well. Typically we use dash mill thickness instead of gauge. That's because mill thickness is standard across the entire industry. Gauge, however, is a little bit different. Gauge can be different based on what type of steel we're using, or if it's used for, say, wiring. Steel gauges are different in wiring than they are in flats or cold formed steel. So we use mill thickness because mill thickness represents the thousandths of an inch thick that something is. So this would be 43 thousandths of an inch thick, which is standard across the board, right? 43 thousandths of an inch is always 43 thousandths of an inch. So in the steel industry, especially for flats, we use this right here. 25 will represent 24. 33 is 22, 30 is 20, and so on. Now, these are, like I said, these are very common to see in the steel industry, but like I said, you will always see this number right here, the mill thickness. That way there's no confusion. This will be how it is in QuickBooks as well, as in the SKU will be mill thickness. So just remember, this is not gauge. Now, this is really easy to remember when you're in the higher gauges, like 97 is definitely not a gauge that we would carry. However, when you get down to the 25 and the 30, this can get a little bit confusing. Now, it is important to note that these are switched, so this is an error on my part that I will fix, but 30 is 22 gauge, 33 is 20 gauge, so let's make sure we swap those. All right, so as I mentioned before, these are the common parts of the steel member that you'll hear referred to, the depth being the width, the flange being the height, and the lip return being the turn in. Now, obviously, with some members, you're going to have one flange, others you'll have two. So like with an angle, you only have one flange. All right, so now we're going to go over all the different types of steel members. So just kind of settle in because this gets a little deep, but we'll go into depth about each steel member. So angle is a very common one. An example name would be 400L400. So 400 being 4 inches, L being the member angle, and 4 being the flange, 4-43. So this would be a 4 inch by 4 inch dash 43, so 18 gauge angle. So a very common angle is 4 by 4, 18 gauge. This is typically what an angle will look like. So they're always L-shaped. They're used in construction a lot. They're usually used to close out angles, to cover up angles. They're used as dead wood for your drywall. They can be used as base angle, or they can be used as a ceiling angle to attach your ceiling trim to. So as with, you'll notice that these talking points are going to be very similar throughout all of the members, but I'll try to highlight the ones that are really important. But I will also send you guys a copy of this PowerPoint so that you can look through it in your own speed or in your own time. So angles are very easy to manipulate. That's why they're used in construction. Typically, people will order these in packs, so like packs of 10 or packs of 20, so that they can cut and use them on site as needed. So you'll typically will not have these ordered by length. They'll be ordered in like large bundles. We use these for pest control. In a much lighter angle, we use these for pest control. So that might be the most common member you're used to seeing as angle. Angle, they're also called lintels. That's where the L comes from, lintels. You'll hear this in construction more. Angle you'll hear in more like pest control applications. Blank by blank, so 4x4, 2x2, 2x3. That's how you'll hear a customer refer to these members. L channel is not as common, but it can be, and then L trim. So just remember, any customer that says these names, that might be what they're referring to. We manufacture all angles here. We can run them from 6 inches to 50 feet. The depth limits are about 1 inch. So the 1 inch depth is about as low as you can go with a angle. Just any lower, and it's hard to get it inside of a break. The 12 inches being the width is about the max, and then the flange is 1 inch to 4.5. So one very important thing about angle is if we are going to roll form the angle, the overall dimension, the overall flat dimension must be at least 6 inches. So that's very important. So a 1x5, for example, will run through our machine. Or a 3x3, no problem. But a 3x2 or a 2x3 will not run through our machine. So we'll be sending that off to fold. So that's very important that you remember what we can run in our shop. So like I said, 6 inches or wider, no problem. We can run it here. 6 inches or less, we will send it off to have it folded at a sheet metal shop. So just remember that when you're pitching it to the customer. That will also limit the length. So if it is less than 6 inches total girth or width, then it will only be 20 foot max width or length. If it's anything greater than 6, we can do it up to 50 feet. So please remember that and put that in your notes. So angle trim can be used for a lot of things. It can be used for framing itself. So it can actually be used to make the structure of a building. It can be used as bracing, very commonly used as bracing to keep walls from getting out of square. It can also be used for things like shelving and applications, which is common. This is a picture right here of that. Base angle is a very common application for galvanized steel or red iron steel as angle. So it goes at the base of the building to have something to attach the bottom of your panels to. Headers, so very important. L headers or lintels are typically used as distribution plates. So I'll go back to that wall. Typically an L header would be used at the top of a door, so right here. So what it does is it goes on the top of the door and it distributes the load out to the outside of the door frame or a window frame, for example, right here. A larger opening may have a much thicker lintel or even a double lintel, one on each side of the wall. So an L trim would help distribute that load out to the sides of the opening. So they are... so that's pretty much it. Like I said, very versatile members, use a lot of different applications. So try to help the customers, with that by selling them basically on, they're very versatile and easy to use. Studs. So studs are the most common member by far. Studs are your main framing member of most buildings. These members can be very heavy or they can be extremely light. We can run these here in the shop, usually 24 gauge. Up to 12 gauge. So an example name would be a 600S 250, very common member here, 6 inches wide on the depth, 2.5 inches on the height or the flange. S for stud, 54 meaning 16 gauge. So a very common member here, kind of like a 2x6, like a wide 2x6. You'll hear these referred to as studs. You'll also hear them referred to as C-channel. Joists, if they're being used for a floor. Rafters, if they're being used on a roof. Drywall studs are usually your very light gauge. I'm talking 26 gauge, 24 gauge, even 29 gauge drywall studs that you be used, very non-load bearing studs. They are closed C-channel as well. So some people refer to these as a closed C-channel. Closed, referring to that lip right there, makes it a closed C-channel. Now, this lip is showing 0.25. You will always have a 0.5 lip. So please remember that if we manufacture the stud, it will always be 0.5. It may be slightly larger, but it will always be at least 0.5. So that's important to remember. So design limits, we manufacture these 6 inches to 50 foot, same as the angle. The depth limits are 2.625 to 12 inches. So this is important. The smallest depth that we can create right here is 2.625. The widest we can create is 12. Flange, we can go from a 1.5, which you're seeing here, up to a 4-inch flange. So anywhere in between, about on a 1/16 of an inch increments. So good talking points for studs. So studs are the thing that we want to sell the hardest. So we need to be knowledgeable about why someone would use studs, metal over wood. So very important talking points. Lightweight. Studs are extremely lightweight compared to wood. They are much easier to handle, which reduce labor costs. All right, so so resistant to moisture and pests. This is a big selling point for metal studs over wood because they do not require any additional pest treatment. And then also, like I said, the resistance to moisture is a big one. Very unlikely to rust or warp or change based on water. And then obviously we use what's called G90 galvanized, which is very resistant to rusting. So big selling point there. Another one's fire resistant. Fire, they have basically a 2-hour fire rating by themselves. So this is a big one, especially for partition walls and things like that. Straight and uniform. All metal studs they're straight and they are manufactured to be the exact length. So if you've ever been rifling through 2x4s or 2x6s or something in a Home Depot, you will appreciate this. So they are all uniform, so they can use 100% of the bundle rather than say 80-90% of the bundle or whatever they're getting, whatever the coal rating is of wood nowadays, which I think is changing all the time, but I know it is getting much worse. Environmentally friendly. So most of our metal is recycled. So that's a big one, and they can be recycled indefinitely, basically. There are very few additives that cannot be recycled. There's very little waste. And then, like I said, studs are typically a little bit more expensive than wood studs up front, but whenever you factor in, like I said, the treatments over time, the changes or fixes you have to make over time and your labor costs, you're typically going to end up, being cheaper with metal studs in the long run. So definitely selling them on the long game there. So C-channel, like I said, very common for a lot of things. Ceiling joists, floor joists, rafters, exterior and interior walls. Like I said, you're just basically talking about an increase in gauge, maybe an increase in depth size. Soundproofing, metal is much better. Ironically, metal is much better about making soundproof walls. When it's paired with soundproof insulation, it tends to absorb sound a lot better, which is really cool. Basement walls are great for metal studs or anywhere that there's going to be high moisture areas. So a lot of these places where you see maybe they're going to be in high moisture areas, Georgia is very humid, so that's a really good selling point for metal studs, is that they will not be exposed to all that, the air, the water that's in the air, things like that. And like I said, so particularly important for basements, applications like that, or applications that are next to water. So track is kind of like your partner with C-channel. So track is always going to be what holds your C-channel. Okay, so track is used primarily at the bottom and the top of a wall to hold the C-channel down or hold it into place whenever they set it. So it can also be used sideways to hold, say, floor joist or rafters or something kind of like a receiver channel, which I'll talk about in just a second. So an example name would be a 450T262 33. So that's a 450, mean 4.5 inches wide. 2.625 would be 5/8 of an inch, 2 5/8 of an inch tall, and then 33 would be that 20 gauge material. So usually track is going to match the gauge of your C channel, not always, but often. It's going to be called either track, U channel, open C channel, top and bottom cap. So you may hear any of these. Open C channel can be confusing because it actually, some people actually call these C channel. So you may have to specify, is that open C channel or is it a closed C channel, or just base it off what they're going to do with it. So if it's going to be load bearing, meaning there's going to be some kind of load on the top of this stud, whether it be another floor or it be, it's supporting, a wall or something like that, it is going to be a closed C channel. Closed means load bearing. Non-load bearing could be a track member if they wanted to use that as a drywall track member, but this is very uncommon. Usually track is going to be used as the bottom, the top, or the side of a floor system. So we do manufacture these pretty much the same parameters as you get with studs. Actually, it's exactly the same parameters you get with studs. just remember, again, that overall width needs to be at least 6 inches wide. So that's important for all of our members, that overall width, because our machine actually won't take a coil narrower than 6 inches. Track, metal track is very easy to work with. I think that's the easiest, the biggest selling point for using metal track is going to be your ease of installation. It has a lot more play than a wood stud and track, or bottom plate wood for wood. Your cuts have to be exact. Whereas with track, you have a little bit of play in the height of your flange that you can move that stud up and down. So it can be great for applications that maybe aren't as level as they should be. It can be much more easy to work with. And then obviously the same benefits you get from the studs, you'll get from the track. So like I said, common usage, framing walls, there you see it at the bottom and the top of this wall, that's your track member. And then here it is on the side where I was talking about, where it would hold some floor joists. Now in this application, it's typically going to be less or the same as the stud. In this application, you're probably going to have it to be a much higher gauge. But in this scenario, you'll probably have the customer specifying the gauge and width and things that they want, so you don't really have to worry about that too much. So flats. All right, so flats are a little bit different than when you think about like a full 29 gauge flat that you're going with in, say, trim work or panel work. A flat for metal steel members is usually going to be strapping, something they're going to use to brace a wall. So you can see this picture here. They go from corner to corner, corner to corner. It helps to square up the wall, and then it helps to keep the wall square during shipping or whenever they're installing it, or it may even add structural bracing to the building, depending on how wide and thick that strapping is. So an example name, it looks a little different, but basically the same. 550 would be a 5.5 inch wide strap, so it looks something like this. F for flat, and then just the gauge, 20 gauge, and obviously there is no flange on a flat, so you won't see a second number. Alternate names, you'll get flats, strapping, or sheets. Strapping is going to be your most common, probably. We call them flats because we do a lot of other manufacturing here at B&M, but your strapping is probably going to be what people will call it. Typically, it's going to be from 1 to 4 inches. Although you can get strapping up to, say, 12 inches. Our limits are going to be 0.25 inches, so a 1/4 inch wide, up to 20.5 inches wide. So if you do have someone that wants heavy gauge flats, or what we would call heavy gauge, say 22 gauge or heavier, we could run it up to 20.5 inches. Now, recoiling is a difficulty. So more than likely, these are going to be laid out on pallets, or in a way that they could load it onto a flatbed truck. So just remember that recoiling capabilities we currently do not have. So if somebody wants, say, 2,000 lineal feet, we're going to have to cut it up or break it up into smaller chunks, because recoiling is not something we can currently do, but we are working to expand that. Flats, your best talking point is just the versatility of what you can do with these things. They're great for filling in sections or making custom clips, making custom connections or stuff on site that maybe the contractor didn't think about. A roll of flats is something they may get with a job just by default. Common uses, mostly these are going to be used for bracing. Like I said, you can make custom straps with them. You'll see them used a lot in plumbing and electrical applications, where they're securing cables and stuff, especially heavy cables. You would wrap strapping around it and then screw it to a wall or a load-bearing section to hold those pipes and cables up. So this is commonly used for that, but it will probably be a lighter gauge. Construction materials, you're probably talking about the heavier gauges, the 16s, the 14s, the 12, to provide actual bracing for a building. This is actually 10-inch wide strapping at 12 gauge, so much, much heavier as you start to put load-bearing applications on these things. So the next one we have is hat channel. So hat channel is a very versatile member. So I have started to, this is where you'll see the talking points start to kind of reduce, because they really kind of apply, the same talking points apply for all galvanized steel members. But an example name, 300H 150-33. That's 3 inches tall from bottom to the top of the height. I'm sorry about that. 3 inches will be the width from this flange to this flange. So hat channels works a little bit differently, but that's your base width, basically what you're going to be able to attach your panel to. H for hat channel, and 150 would be the height. So we have a 1.5 inch and a 2.5 inch hat channel here that we run at B&M. And we run it from about 24 gauge, I think, at the thinnest, up to I believe a 20 gauge. So it's not as, there's not as many versions of hat channel, but also you're not going to have people ordering custom hat channel. Typically, they're just wanting hat channel to use to attach their panels to the side of a building. So alternate names, they may be called a top hat member, a hat channel, hat, or metal furring strips. So this one's kind of a weird one that you'll hear people talk about when they want some furring strips. This is what they're talking about. Or even lathing strips, something that you could put on the side of a building or the roof of a building to put panels down on top of. So imagine that this is the alternative to, say, a 1x4. If you're lathing the roof with a 1x4, you could also lathe it with hat channel. Like I said, it is well worth the upsell to get people to go with the metal application, just because of, like I said, the corrosiveness, the pest, the moisture, the exactness. This is a great upsell from that 1x4. So yeah, it's a very reliable, very easy to use roof purlin. It can be used on the walls or the roof. And they have pretty good spans. We're talking 5 foot, I believe, 5 foot spans. So a very good member. We run them here, 12 inches to 40 foot. And then that's pretty much it. We do run them to length as well. So we used to only sell them in 20-foot lengths. We now run them to length. So this is important for the customer. Common usage, you'll see, like I said, roof framing, ceiling framing, and walls. So basically, this is your hat channel member. It's going to run perpendicular to your load-bearing studs or trusses or whatever, and become something that you can put, say, soffit panel on top of. If you have a customer who wants to run soffit panel parallel to their trusses, then they would need hat channel to put on the bottom so that they could turn their panel this way and run this way. So very common. Same thing for walls. If you want to run a panel vertically, you must have a hat channel in order to run it vertically. So Z's. So Z's are the first item that we do not manufacture at B&M yet, for now. We may amend this in the future, but for now, a Z channel, we do not. Now, a Z channel, a good way to think of the Z channel is a much heavier version of your hat channel. It serves almost the same purpose. It braces the building parallel to, or perpendicular to the trusses, and it also allows for a load-bearing purlin that can span much, much further than a hat channel. We're talking 20, 30-foot spans for Z channel. Very strong member that are primarily used with our ACT building system. So there'll be a training that comes out for building types. Our ACT building system uses Z channel. Red iron buildings also use Z channel as well. So 450Z 200, this is just referring to the depth. The depth of a Z comes from this corner to this corner, your longest part. And that's typical with most steel members. Your longest, widest part is going to be your depth. So the Z, referring to Z channel, 200 would mean the lip height. So from here to here is your your flange height would be 2 inches. 30 would be 22 gauge. We have a very lightweight Z channel. Typically Z channel you're going to see from 16 gauge to 12 gauge, but you can have light gauge ones as well. So they are called Z channel, Z's, Z purlins, metal purlins, roof or wall purlins. So this purlin word is important with Z's because purlins are what they've been called in the red iron industry for so long. So you may hear this word a lot. They're just referring to something to put their metal panels on top of. A wood purlin would probably be a 1x4 or a 2x4. A Z purlin or a hat channel purlin is going to be a metal equivalent. Z's are extremely strong, just your talking points for sales. Very strong member, very reliable. The shape of them makes them very, very reliable. And then again, they are corrosion resistant. We do outsource these, so we purchase these from a number of vendors, 12 inches to 40 foot. The depth limits for now are 4 inches, 6 inches, or 8 inches. There is a 10-inch Z as well, but you will rarely see that happen. Flanges are 2 inches or 3 inches, so if you imagine a 4x3 or a 6x2 Z channel is how you'd be ordering those members. So common uses, like I said, basically the same thing as hat channel. They're used as roof, wall purlins, joists, or for flat ceiling. So the only other instance is when you'll see, other than just purlins like this, going perpendicular to the roof, rafters, or trusses, would be a joist ceiling made of Z's. Now, if someone's going to put concrete on a flat ceiling, Z's are a pretty good option. They're very strong and they'll span a long way. So you may see that application, but it is not very common. It's kind of an older practice, but just in case, it's here for reference. I think we have one more. So one more member, and it's a pretty niche member. So this is something that has a very specific application, whereas the other members, you can use them for a lot of things. This is going to be a very specific item. It's called an eave strut. Now, an eave strut serves as the last purlin member of your building. It goes at the top. And if you can imagine an eave trim, that's where the eave purlin goes, just below the eave trim. So your eave trim that we make, the 2x2 with a kick out, would go down, down, and out. So basically this is what you would attach your gutter to. It's kind of like a fascia cap. It is the last of your roof whenever you're doing a metal building. So eaves are a little bit different in their naming convention in that they will have one extra pair or tuple of numbers. So this tuple of numbers will specify the bends of the eave trim. So in this example, this 350 would be the depth. So that's A, the depth of the eave, remember? The 162 would be the flange length. So that would be C and B, which would be 162, or remember 1.625 inches, 1 5/8, a 20 gauge member. And then you'll have this tuple here. This tuple refers to the degrees of the bends, okay? So your first tuple, or your first member, 18.43 degrees. That's roughly a 312 pitch, I believe, or a 412 pitch. I have to check, but let's say it's a 412 pitch. So 18.43 degrees would be this bend right here, meaning that from here, from a flat surface up, is 18.43 degrees. Same thing for this one. This one would be 18.43 as well. Again, you would have this bend from a flat surface up, 18.43. So this specific eave trim here would have matching legs. So it would go up for its top leg, and then it would go up for its bottom leg. This is pretty common. It's called a double sloped eave. So a double sloped eave trim would have two slopes. A single sloped eave trim would be like this one, and it would have one slope. Both are common. So if a customer orders one, they will need to specify the both of the angles. All right. Typically, this is going to be a 90, and then this will be the pitch of the roof, or this will be the pitch of the roof, and this will be the pitch of the roof. So that's one way you can help the customer get to that angle. If they're not sure, you can ask them the pitch of their roof, and we can match that. We outsource these as well from the same vendors that we outsource Z-Channel from. So remember, we're going to order these in. We will mark them up. We will process them by labeling them, cutting them, altering them in any way, and then we will sell them out. So just remember, that's important. So lead times are a little longer on eave trim. So 12 to 40, the exact same increments as C-Channel. So eave's a little bit differently. Eave you can usually run in the same increments as C-Channel, because the machines that we use to manufacture these typically just create a C and then bend the top or the bottom and or the bottom up. So they're usually the same parameters as C-Channel. Really important is the degree. Up to about a 30-degree pitch is about the maximum we can do. All right, so we have to be very careful about that with eave trim. Eave trim will not do well with a 12-12 pitch. A 12-12 pitch is a 45-degree angle. If that is the case and the customer needs that, it will require special pricing. So just make sure to note, under about 30 degrees, we should be able to order it from our vendors. Anything above that, we should probably look at special pricing or give them a, an IOU for the price, and then we'll come back to them. So yeah, just that, like I said, the pitch is the biggest concern with eave struts. And again, they have one use. They're used at the eave of the building. So you can see right here a red iron building that has a galvanized eave strut running down the side, which creates that last purlin. And then you imagine you'd have Z purlins, Z, 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 and then they would line up with the outside of that eave strut. So that's important to know. And then this is the much closer look of why, how that goes the way it goes and why it serves, that important purpose of kind of setting your roof line as well. All right, so a couple more slides, and we are almost done. I know this is a long video, but I appreciate you guys hanging in there. And like I said, keep it for your reference and watch it as many times as you want, and feel free to ask me any questions about these members. The quoting process for these members is pretty simple. As long as you follow the steps below, you should be just fine to get a quote for these things. So B&M products are hat channel, studs, track, angle, and flats. You fill out a quote form, which is the same quote form you can use. You can use the same one you use for every member we have at B&M. You only have to make sure that you get these 4 things: the depth of the member, the flange of the member type, and the gauge. As long as you get these things, then we'll be able to interpret that stud. Whether it's in QuickBooks or not, I'll be able to get you a specific price. Record the quantities and the links for each member. So same way you do with panels, you will get a quantity and links. So a lot of times people will order a large quantity, but in a exact length, or they will have many quantities and links similar to panels. So just remember that. Use the QuickBooks to quote. So this pricing is in QuickBooks. We have about 30% of our still members in QuickBooks now as of this recording, which doesn't sound like a lot, but it is, considering there are probably 800 or 900 different members if you do all the different variations. So most common members will be in QuickBooks. If they're not, it's no problem. Make sure to do a calibration fee of 6 feet for each separate member. So this is important. If you have a 2x6 member, you need to put 6 feet extra on that quote as a calibration fee. So if it's $2 a lineal foot, you will put $12 on that piece as a calibration piece. And you can put calibration piece as a line item on QuickBooks, that's fine. So do that for every separate item. So not every separate length or member, but every separate profile. So if you have a 2x6 and a 2x8, you'll have 2 calibration fees. No matter how many panels or how many quantities and links, you'll have 2 calibration fees. And finally, if it's not in QuickBooks, if it's not in the computer, just submit it to me or the Light Gauge department, and we can get you a custom quote on that member. So we will never have all the pricing for still members in QuickBooks. There's just too many. I mean, there is basically infinite. If you think about a 1/16 of an inch increment, there's basically an infinite number of still members. So if you happen to get one that's not in QuickBooks, just submit it to the Light Gauge department and we'll get a quote for you by hand. Outsourced products are even simpler. Same steps: fill it out with the depth, flange, member type, and gauge. Record the quantities. Email the quote to the proper vendor. So it may be McElroy, it may be Metal Sales, but we want to email it to the proper vendor and they will make sure to give you a price. If you have trouble with this process, again, just submit it to the Light Gauge department and me or any of the other guys can get you a price pretty quickly. So ordering. Ordering is a little bit more complicated because we do not keep all coils in stock. We do not have master coils. We have specific width coils right now. So checking inventory is very important. So the first thing you'll do is, and I don't know why I didn't write this on here, but let's assume I did. The first thing you'll do is check inventory. All right. So check with the Light Gauge department for a lead time, because if we have the inventory in stock, it will be very quick. Steel members can be ran in 24 to 48 hours. If we do not have the coil, it can be anywhere from 2 weeks to 6 weeks, depending on the vendor and the time of the year. So really, we want to make sure that we get a lead time first. Once you agree with the customer on a lead time, you can collect the down payment of 50%. So we do steel members the same way we do metal buildings. They are a fully custom manufactured item, so we cannot resell them very easily. So we do a 50% down payment. Once the customer has confirmed the order, submit the order to the Light Gauge department, and we will put it in the queue for manufacturing. The Light Gauge department will contact the sales team once they complete the item. Once the customer has picked up the item, the front office will print the ticket for the customer to pick up, same as in the old yard. And then the Light Gauge department will load the customer and file the order away. So once the sales team has handed the order over to the Light Gauge department, your side of it is pretty much done. So we will take care of it. We'll file it in our own filing system. Should be pretty easy. And then you will collect full payment when you print their ticket. So when you print their ticket, they should pay the rest. So specs, really quick. This is just some dry spec stuff, but it's important to know because you may be asked this. So let me go ahead and put this in. All of our Light Gauge members are coated in galvanized. Galvanized is a coating. It's basically raw steel that is coated with a zinc compound. So very important that you understand that galvanized is not a type of metal. Galvanized is just a raw metal that has been coated with a zinc coating. Now, this zinc coating is much more resilient to wear and moisture than, say, I have a typo here, than, say, Red iron coating, much more resilient. It is actually, it's dipped. It's a dipped compound and not sprayed on like red iron. So it keeps the member from rusting much longer. If anyone asks, G60 versus G90, G90 is a galvanized coating. We only use G90 here. If we ever sell G60, we will specify specifically, and it is typically a little cheaper. So we use what's called G90, and it is much more resilient than G60 to corrosiveness and weather over time, especially in environments that have any kind of salt water or water spray. Manufacturing. So again, this is just a good talking point for if anyone wants to know the difference between galvanized and red iron. Okay, so galvanized is cold rolled. So what that means is when we form a galvanized member, it is cold. It is room temperature or it is colder. This is opposed to a hot rolled like red iron. Red iron is formed when the member is still very hot. So why would customers want this over hot rolled? Cold rolled is stronger. All right, so it is generally stronger and much harder than hot rolled members. Hot rolled are typically a little cheaper to produce, but they are not as rigid and strong as a cold rolled member. So we do try to use as much cold rolled product as we can. The surface finish of a cold rolled member is much smoother. So red iron members can get a lot of bends. They can get imperfections, spots where they start to twist. Cold members do not do that, which is really nice. They are also much more accurate than a red iron member. So their tolerance is usually within 1/4 of an inch. We're usually within 1/16 of an inch, and sometimes we'll hold within 1/32. So much more accurate. And then they don't warp as easy. And that's a big one for places like Georgia where the heat changes constantly. So when you get environments where it gets hot, then cold, then hot, then cold, metal likes to expand and contract, and it will wear over time and it can warp. Cold roll members do not do that. So it's a really good, like I said, these are good little talking points for if someone wants to be educated about why we use galvanized steel at B&M rather than hot rolled. So I will say definitively at the end of this slide that galvanized members they're kind of the best product. So if we're trying to sell these members, I would sell them as this is the top of the line product. If you want to build something and you want to make it long lasting, you want it to be strong and easy to work with, this is by far the best building product to use. Now there are positives to other alternative methods such as hot rolled red iron, tube framing, wood framing, but overall as far as strength and quality, this is going to be your best product. So that's kind of what we want to sell them on, is that this is, the top of the line product. If they want a quality thing that's going to last forever, this is the way you go. So guys, I appreciate you listening to this recording. Hopefully my voice held up enough for you to understand everything. If you guys have any questions whatsoever, please do not hesitate to reach out to me, alex.bryan@bmmetals.com. And I look forward to putting out more of these training videos. If you have any feedback on how I can do better with these, please let me know. But good luck, and go out there and sell this stuff. Thanks, guys.